Derivatives with E, Quotient Rule, Lagrange's notation. So, as I explained in previous videos, that if you have a function with e to the power of x, then the derivative of that function is e to the power of x. If you have e to the power of kx, k being a number, the derivative of that is ke kx, or the number times e to the power of the number times x. If that doesn't make sense, I would recommend watching one of my other videos which tells you more about this. It's a chain rule video, or if you do understand this, keep watching, or if you want to learn more, watch all of them by all means. But that's the gist of it, with having derivatives with e. Now this is just a rehash of the procedure we're going to be following when we're doing the quotient rule. You have a function divided by another function within the function I've called h. The derivative of that h function is the derivative of f multiplied by g minus f multiplied by the derivative of g all over g squared. On that note, let's start an example. So, example 1, let's say hx equals x squared over ex. If it was a function over a function, which it is, then we would follow the quotient rule. So fx over gx, x squared over ex. Let's separate the page and label them as such. And the formula for the derivative is the derivative of fx multiplied by gx minus fx multiplied by the derivative of gx all over gx squared. So we need to find the derivative of fx and the derivative of gx. The derivative of fx, which is 2x, and the derivative of ex is just ex, like I said before. And so if we fill this in, what we get is the derivative of fx, 2x, multiplied by gx, which is ex, minus fx, x squared, multiplied by the derivative of gx, which is just ex, all over gx squared, gx being ex squared. So, if we were to simplify this a bit further, this also equals that is because if you were to expand this bracket, we're just factoring out the ex. If you were to expand these brackets, you'd be multiplying ex by 2x, same as here, and then multiplying ex by negative x squared, which is the same over here. And so now you can see that we have ex, and you can divide, because we have ex and then we have it over ex squared, we can take the square away, and we can also take this whole ex away. So what we're left with is 2x minus x squared over ex. Makes it look a lot neater, and it simplifies it. So if that doesn't make sense, then I'll keep watching, because we're going to do some more examples, but maybe watch it again until you understand it if it's really confusing, or watch other videos that I've made if you really don't get it. Because I'm speeding, as I make these videos in the playlist, I'm speeding up through them a bit more. So example 2, hx equals x squared plus 3e to the power of x all over 4x. As again, we have a function over another function. If we were to label them, fx would be x squared plus 3e to the power of x, and gx would just be 4x. Now the formula for the derivative is the derivative of fx multiplied by gx minus fx multiplied by the derivative of gx all over gx squared. So we need to find the derivative of fx, we need to find the derivative of gx. So the derivative of fx is 2x plus 3ex. That is because the derivative of x squared is 2x, and the derivative of 3ex, the 3 stays there. The 3 only disappears if it's a number by itself. So the 3 stays there, and you multiply it by ex. Because the derivative of e to the power x is e to the power x, you end up with 3 times e to the power of x. It's the exact same. And the derivative of 4x is just 4. So if we were to fill this in, what we end up getting is the derivative of fx, 2x plus 3ex, multiplied by gx, which is 4x, minus fx, which is x squared plus 3e to the power of x, over gx squared. Gx being 4x. Oh, forgot to. Hold on, I'll rewrite this. Derivative of fx, 2x plus 3ex, multiplied by gx, which is 4x, minus fx, which is x squared plus 3ex, multiplied by the derivative of gx, which is 4. And all of that is over gx squared. So that's 4x squared. You can simplify this further, but I'm not going to. But you can. I'm sure this is a good enough step to finish on if you have someone who's marking your work. But obviously ask them so you don't get it wrong. But anyway, that's a story for another time. Example 3, hx equals e to the power of 3x over cot x. So we know that fx over gx, function over a function, we'll label fx as e to the power of 3x, and we'll label gx as cot x, or cotangent x. The derivative of hx would be the derivative of fx multiplied by gx minus fx multiplied by the derivative of gx, all over gx squared. So again, we have to find the derivative of fx and the derivative of gx. the derivative of fx, before we had e to the power of kx. When you derive that, you get ke to the power of kx. Just like the k being a number, when you have e to the power of 3x, the derivative is 3e to the power of 3x. And the derivative of cotangent x is negative cosec squared of x, running out of room. So, if we were to fill this in, we'd end up with derivative of fx, 3e to the power of 3x, multiplied by gx, gx being cotangent of x, minus fx, which is just e 3x, multiplied by negative cosec squared of x. So the things that are in common with both, squaring the gx. But the things we have in common on the top are the e3x, because it's multiplied to the cotangent and the 3, and then we also have it multiplied to the negative cosec squared. So, if we factor it out, we end up with e to the power of 3x multiplied by 3 cot x minus plus cosec squared x all over cot squared x. Okay, so the reason I've done this is because one reason is it makes it simplified and neater, but if you were to expand these brackets, you would get this. So if you were to multiply e3x by 3 and cot, you would get 3e3x cotangent, and if you were to multiply it by cosec, you would still get the same thing. The only reason I made this a plus is because there's a negative cosec and there's a minus sign here, so that would make a plus. I hope this made sense. If it doesn't, watch it or learn from other videos. I hope they help. Thanks for watching.